Thank you very much and welcome to today's session where we are looking at 2017 Paper 1 GC question 18. So the question is on bearing. The question reads, A, B and C are 3 points on a level ground. B is on the bearing of 070 degrees from A and C is on the bearing of 130 degrees from B. Here is the diagram of the bearing. Then we are asked to calculate the bearing of A from B and B from C. So, when you meet a question on bearing, there are certain conditions that you should bear in mind. Some of these conditions that I would like to share with you are these. Uh, Whenever you want to calculate for bearing, first make sure you create north poles on every end of the triangle. On every edge of the triangle, create north poles and extend the lines. You extend the lines when you create the north poles. This helps you to understand how the angles will be rotating. So create the north poles on every edge of the angle. So it is good that on these two edges we are given the north poles. So meaning you just have to extend them. When you extend the north poles, on C we are not given the north pole. You also draw the north pole and extend the line, so that it will be easier for you now to start applying the rules that are involved in bearing. The first rule is that when you want to rotate bearing or you want to find the angle in bearing, you always move clockwise. Example, if this is the North Pole, a clock moves in this direction. So you always move clockwise until you meet the line mentioned. Then the other point is this one. When you read your statement like this one, where you've been asked to say, calculate the bearing of A from B, it means you stand at B, then you start rotating in the clockwise direction until you meet the line that is attached from B going to A. Until you meet the line that is attached from B going to A. That's how we calculate bearing. So in this case, the other point that I usually emphasize to my learners is this. When you are given a mathematical diagram to solve, be it on bearing, be it on circle theory, or any other, first work out certain parts that you know before you go to the questions, where you tell yourself, okay, I've been given this diagram, but what do I know from the diagram? I know there is 70 there, I know there is 130 there. What angle is there? You start putting in those angles that you feel you know, so that it will be easier for you to pick the answer after you've identified the angle. So we start from there. We know from mathematical language that when you have a straight line, it actually adds up to 180. So if a straight line adds up to 180, we have an incident where we are given an angle which is not actually up to 180. We ask ourselves, what angle is missing for me to create a 180? That's the angle that is here. So what angle is there? 50. So we say here we had 50. So that when we complete it all, it will be 180. Because we know a line actually gives 180. From 0 to start rotating until it meets the straight line, which gives us 180. The other one is this. We call them actually the corresponding angles. Corresponding angles add up to 180 as well. Which one are corresponding angles? We start asking ourselves. So if I have a 70 here, the angle that should be here actually should give me, when I add 70 plus the angle that will be here, they should give me 180. Why? When angles are facing each other, they give us 180. And angles that face each other, in mathematics, we call them corresponding angles. So here I have a 110. Because 110 plus 70 should give me 180. Then ask myself, if I have a 110, what is missing here is actually a 70. Sorry for that. In other language, they say alternate angles are equal. If angles are forming a zigzag, they are called the alternate angles. These angles are equal. Then corresponding angles are like this. An angle which is here is plus which is here, which is x plus y should give you 180. They are called the corresponding angles. These are called the alternate, these are called alternate alternate angles. These are called alternate angles. So these three conditions are actually the ones we usually apply most of the time on bearing. Again, we can know the angle that was here. We call them alternate angles. Alternate angles, if we have a 50 here, I also have a 50 here. Are we there? Which can also actually help us to know what we are looking for. So now we keep moving. Where we say, if I have a 70 here, then I have to know which angle is actually from here up to here. I have a 110. These are called the alternate angles. The angle that is from here coming here is actually this 130. So now we go to the questions. They have said calculate the bearing of A from B, meaning you stand at actually B, then you move until you meet the line that is going to A. This is what it means. You stand at B, then you start rotating in a clockwise direction until you meet the line that is going to A. So we are going to add 130 plus 50 plus 70 to find the angle we are looking for. So we say we add all those, or we go by the simpler way. We just subtract 110 from 360, because we know if we add 110, it's going to give us the whole circle, which is 360. But it won't be a complete 360 because there is 110 which we shouldn't add from there or angle. So it will be 360 minus 110, which gives us 360 minus 110, it actually gives us 250. So the angle we are looking for was 250, the bearing of B from A. We go to the next question where they are saying calculate the bearing of B from C. So you stand at C until you find the line going where? To B. So you start rotating in this direction. This is the North Pole. I said you start rotating in a clockwise direction. So we know the line that is going to C is actually B from C is this line. But you don't move in this direction. No, you move in this direction until you meet this line. This is the right way. So meaning we also do the same from the old circle. We subtract from 360, we actually subtract 50, then we have 310 as the angle we are looking for under bearing. Thank you very much. We end here today.